Today we're going to be graphing from slope-intercept and from standard form. Yesterday we talked about changing standard form to slope-intercept form and how to write equations in slope-intercept form. Today we're just going to be graphing with that. Okay, so this is again slope-intercept form, y equals mx plus b. My b is my starting point, that's the y-intercept. You made that note yesterday hopefully. My m is my slope. And remember, the slope yesterday we talked about the formula y2 minus y1 equal to x2 minus x1, or over x2 minus x1. This is just going to be helping me graph. My rise over my run is what I'm going to use today for my m. The two are the same. This one just helps me graph. The other one yesterday helps me find the actual slope. Okay, so we're going to do some examples of graphing these lines. All right. My first example, write this down. You've got y equals 3/4 x minus 5. Okay, so that's already in slope-intercept form. I have a y, I have my m, and I have my b. Y equals mx plus b. My slope, I recognize that's before my x, it's 3/4. So my slope is 3/4. And then my y-intercept, I've circled or boxed in, is -5. Okay, it's the number at the very end, the last number, that's always my starting point. And I circle the whole thing because the minus sign in front tells me that it's a -5. So I got my slope, I have my y-intercept. And then I made a note, this is just rise over run again. I made myself aware that my 3 is going to be my rise, my 4 is going to be my run. So that's going to help me graph starting from my y-intercept. So start at 0, 0, 0, start at the origin. You're going to go down 5 because my y-intercept is -5. So I'll go down. Starting at 0, you go 1, 2, 3, 4, 5. Okay, so at that point you put a dot. Right now you should only have a dot on your paper. You should not just have a random line trying to match what I have here. Because if you have just a random line and no dots on your paper, that shows me you don't understand what you're doing. That's just trying to make it look like what I have, and I don't like that. I want you to understand that this is a dot that you need to have at -5. From this dot, we're going to make another one using my slope. And again, my slope was 3/4. I'm going to rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. So this is my second dot that I have on my paper, on my graph. So I should have 2 dots already on my graph. You should not have a line yet. Once you have your 2 dots, then you can connect them, and going through the dots, have a line. At the end of the line, make sure you have your arrows. So if you just randomly have a line without any dots or any location points on your graph, that shows me you don't really know what's going on. You don't know what the y-intercept is. You don't know what the first point from the slope is. I couldn't tell you what the slope is of a line if I didn't have 2 points that I'm counting from the y-intercept to. Okay, so I need to have dots on your paper, that way I know you understand the slope and you understand where the y-intercept was on this y-axis. Okay, so that's example number 1. Example number 2, a little different. It is, wrong way. Y minus 1 equal to 1/2 x plus 1. Now this is your given equation. This is not slope-intercept form. It's not standard form either, but we need to change it to make it fit y equals mx plus b. So if I notice right here, I have y minus 1. To get rid of this 1, so I can only have y by itself, I'm going to add it. It's just the inverse of minus. You add it to both sides. And you only add it to the things that are like terms. My 1 and 1 are like terms. My 1/2 x here is not a like term with this 1 that I'm adding, so I'm not going to add it to my 1/2 x. So once I add my 1 to both sides, I'm left with y on this side. 1 plus 1 becomes 2, and then my 1/2 x just drops down because nothing happened to it. So now I have y equals mx plus b form, a slope-intercept form, where I have a slope of 1/2. So I'm writing m equals 1/2, and you can write rise over run if that helps you. If it doesn't, if you don't need it by now, that's fine. Go ahead and circle your whole +2. Okay, just like in the previous example, I had a -5. Well, here I have a +2. Yes, that is +2, but that's also a positive symbol. So you can go ahead and circle the whole thing. And I just made a note that that's my y-intercept, that's my starting point. I always start with my y-intercept. So we're going to use this to help us graph. So on your graph, you're going to start from the origin, you're going to go up 2. That's where you're going to be. You're going to have your first dot. That's your first point that you're going to start with. So put a dot at +2 on the y-axis. From there, I'm going to rise and run. My rise over my run was 1/2. So I'm going to rise 1, and then I'm going to run 2. So you're going to go up 1, and then over 2. Up 1, over 2, up 1, over 2. That's 4 dots going that way. If I wanted to go backwards, I'm just going to do the opposite of what I did to start with. So I'm going to go down 1 and then to the left 2. Down 1 to the left 2, down 1 to the left 2, and that's as far as I can go to fill up my graph. So you should have 1, 2, 3, 4, 5, 6, 7 dots on your paper. And again, if you just have a random line somewhere going across and it looks like that, but it's not really that because it's not going to have these dots. You need to have these dots on your paper. That includes on a test, on any classwork assignment, on a quiz. I need to see that you have a y-intercept and then you know what the slope is based off your 2 dots here. Okay? So that is example number 2. Number 3. Number 3 is standard form. It is 4x plus 2y equal to 8. Yesterday we talked about changing standard to slope-intercept. Now you have to show it and then be able to graph it. So we're taking it a step further from yesterday. Okay, so we got 4x plus 2y equal to 8. First step, I want to get rid of everything over here. So I'm going to subtract 4x. When I subtract 4x, I'm left with 2y equal to negative 4x plus 8. Then I just need to divide by that 2 in front of my y because I want to get rid of it. And I have y by itself. So then I have y equal to negative 2x plus 4. My negative 4 divided by 2 is negative 2. 8 divided by 2 is positive 4. Again, when I circle my y-intercept, remember to circle that sign in front of it. That tells you where you start. Do I go up on the y-axis or do I go down? For this case, it's going to be up because it's a positive 4. My slope was negative 2. Now, I don't have a fraction here, but I can make it a fraction by placing a 1 underneath that negative 2. So then I have a negative 2 over 1, my rise over my run. So, go to graph. When I graph, I start with my y-intercept, go up, positive 4, 1, 2, 3, 4, put a dot there. Because I have that dot there, I know I start here, and then I'm going to use my slope. Now my slope is negative 2 over 1. Instead of rising, I'm going to have to go down because my top number is negative. So I'm going to go down 2, and then over 1, down 2, over 1, putting a dot each time I go down 2 and over 1. And I just place a dot right there. Down 2 over 1, so I should have 1, 2, 3, 4, 5, 6 dots. And then to go backwards, I just go the reverse direction. I go up 2 and then to the left 1. Okay? So if you are watching this, you can pause it, replay this, rewind it, and see how I graph that line if you're confused at what I did there. So that is example number 3, changing it from standard form to slope-intercept form and then graphing it, taking it a step further from yesterday. All right. Example number 4. I believe is also standard form. Let's see what we got. Yes, standard form, negative 3x minus 9y equal to 18. In this case, we have a negative and a negative. I think up until now, we've only had positive x values out here. This time, I need to get rid of this 3x just like normal, but I'm going to do it differently. Because it's negative, I need to add it to both sides. Okay, I'm going to move this 3x over here so I can get my y by itself. I add 3x to both sides, left with negative 9y. There's a minus sign in front of that 9, so I need to bring it down. I have negative 9y equal to 3x plus 18 because this 3x becomes positive now. Remember, even when you're doing it by yourself, to always bring down what's in front of your y after you get rid of the x value. Then my next step is to divide by negative 9. When I divide by negative 9, my 9's cancel out here, so I'm left with that y, which is what I wanted. I want slope-intercept form, whereas y is by itself. Then I divide 3 and negative 9. That doesn't divide evenly, but it can reduce. 3 can go into both 3 and it can go into 9. So 3 divided by 3 is 1. 9 divided by 3 is 3. I look at my signs, just like yesterday. My signs are different, so there needs to be a negative out front. Okay? My other fraction, 18 divided by 9 is 2. Okay, divide 18 and 9, then you get 2. And then I look at my sign. I have a positive and a negative, so my signs are different. I need to have a negative out front. Then I just circle what I know. I know my y-intercept is this whole value at the end. That's my starting point, which is negative 2. And then my slope is going to be this fraction right here in front of my x, negative 1 over 3. So to go into graph that, we're going to start with the y-intercept. It is a negative 2, so I'm going to start going down first. So I go down 1, 2, place a dot there. From that dot, I'm going to use my slope. Now my slope again is negative over a positive, so I'm going to start by going down first and then to the right 3. So I go down 1 over 3. Down 1 over 3. That's as far as I can go this way. If I want to go the opposite direction just to show that my line extends itself all the way out to the end of the graph, I'm just going to go up 1 and then to the left 3. Up 1 to the left 3. Okay? Then I just connect my dots after I have placed them on the graph. It should be very easy to make that line after you have your dots. If you just have no dots and you're trying to just draw a line, it's going to be very difficult for you. At the end of your line, make sure you have your arrows to make it a complete line, just not a line segment. Okay, so that is example number 4, changing it from standard to slope-intercept and then graphing that line. All right. Got one more example with 2 different lines on it. So this is number 5 and it's also number 6. Number 5 is y equal to 2. Number 6 example is just x equals to -3. Now these lines are very simple. They look easy, but they're kind of difficult when people try to think about graphing a slope and graphing the y-intercept because they don't have a slope. Neither one of these have a slope that I have to count a rise over my run. When I have y equal to 2, imagine this is a y equals mx plus b, except you don't have the mx. You just have the b here. This is just y equal to some number. This is the number at the end. So when I have y equal to 2, I just go like I would normally, start with 2. This is my y-intercept. I go to my y-axis and place a dot at 2, just like I normally would. But now I don't have a slope. And because I don't have a slope, the slope is 0. It's going to form a horizontal line. So I just draw a line through that y value at positive 2. Very easy, but people get messed up because they don't have a slope to graph. So you just place a dot at positive 2 on the y-axis, draw a line through it, make sure you have your arrows, and that's that line. Very easy. Same goes for this. This is x equals. This is no longer y. It is x equals -3. So you can think you have a y-axis, you also have an x-axis. You're going to graph this value on the x-axis because it's x equals. Okay, when it says x equals, I know it's going to go through my x-axis. So to graph it at -3, I go to the left, 1, 2, 3, place a dot on that x-axis, and I simply draw a line through the x-axis at -3, making sure I have my arrows at the end. Okay, so when it says y equals, I know I'm going to start on the y-axis. But when it says x equals, it's going to cross that x-axis. Okay, no, it's not going to cross this y-axis ever. It's going to run parallel. So everybody knows what parallel looks like. Hopefully you can see that these 2 lines are parallel when it says x equals equation. So those are 6 examples for you that you have graphed. We're going to practice that, and if you have any questions, just rewind the video and go through it again.